Here we are in section 1.4 exercises, part A, with the solutions to numbers 1 through 13. Read the instructions. Find 4 different names for each fraction. So here's an example. They take 3/11ths and they times it by 2 over 2 to get this. They times by 3 on the top and 3 on the bottom. 4 on the top, 4 on the top, 5 on the top, 5 on the bottom. And they keep multiplying them by different numbers, and you can get any number of fractions, any number of names for this particular fraction that you would like. So let's do it. 3/7. 3 times 2 will give you 6. 7 times 2 will give us 14. Good. What if we do 3 over 3? 3 times 3 is 9. 7 times 3 is 21. Do 4 over 4, you can get 12 over 4 times 7 is 28. You could do 10 over 10, so we get 30 over 70. As long as you times by the exact same thing on the top and the bottom, you'll get a new name for that fraction. Let's see what the answer looks like here. Oh, there we go. Those are some of them that we used. But then, they did a 7 over 7 where we did a 10 over 10. No problem. This means that there is flexibility as long as you have answers that are the same thing. All right, let's try 2/3. We'll do some easy ones. Times by 2 over 2, that'll give us 4 over 6. Times by 3 over 3, that'll be 6 over 9. Times by 4 over 4. 2 times 4 is 8. 3 times 4 is 12. We could times by, let's do one like 9 over 9, just for fun. That'll give us 18 over 27. And double check those. Yeah, those are some of the ones we used. Oh, we didn't use the 5 over 5 or the 6 over 6. But we used some of the others, and yep, that's perfectly fine. Number 3, 7 over 11. Times by 2 over 2, it's 14 over 22. Times by 3 over 3, that's 21 over 33. Times by, 8 over 8, we get 56 over 88. That's correct. And let's do 11. 11 over 11. We get 77 over 121. See how many of ours matched up with the back of the book. Yep, that one and that one. Oh, then they did 4 and 5. They did kind of boring. It's perfectly fine if you didn't match up exactly with their answers. Okay, 4/9. I always like 2 over 2 because that's the easiest one. Times by 2 and 2, and we get 8 over 18. 3 and 3 would give us 4 times 3 is 12. 9 times 3 is 27. 5 over 5. 4 times, I'll write that one out so we can see what we did. We times by 5 over 5, which indeed was this is really all we're doing. It's a special 1. 4 times 5 is 20, and 9 times 5 is 45. Good. And then we get, let's try another one. 10 over 10. That's a nice easy one. 40 over 90. Yeah, I like that. And there we go. 8 over 18, 12 over 27. So we matched a couple of them, but yeah, there are a bunch of others. There are billions of other answers that you could have. Okay, number 5. This says to simplify, which means we've got to go the other direction. Somebody already multiplied it by some stuff, and we've got to go down, backwards. 36 and 52. That looks like kind of a toughie. They're both even numbers. They end in 6 and 2, so let's do that first. Divide by a 2 and divide by a 2. So just opposite of what we did up here with multiplication. 36 divided by 2, that gives us 18 over 26. They're still even, so we can divide by 2 again. If they're even, they always go, 2 will always do it. 9 and 13, I think that's about as far as we can go there. 9/13. Let's check the answer. 9/13. Good. Number 6, 27 over 36. Now a 3 goes into both of those. 3 times 9 is 27, and 3 times 12 is 36. But I think also a 9 goes into them. Let's see if we can do it all at once. Divide by a 9, divide by a 9, and we get 3/4. So let's check our answer. 3/4 indeed is correct. 16 over 56. I'm going to use for this one that special thing we learned with prime factorization. If we take 16 and find out what it's made up of, 4 times 4, 2 times 2, 2 times 2. So this is actually 2 times 2 times 2 times 2. on the top, and then 56. Let's break him up and see what he is. 56 is 7 times 8, and that's 4 times 2, and that's 2 times 2. So we get 7 times 2 times 2 times 2. And we can see there what's happening. This is just a fancy 1. Look at that. That's a fancy 1. And that's a fancy 1. And that's a fancy 1. And 2 divided by 2, that's what we mean when we say it cancels something out. 2 divided by 2 is a 1, which kind of goes away when you're multiplying. So it simplifies down to 2/7. Let's double check our answer. Indeed, that is correct. Number 8, 10/12. I recognize both 10 and 12 from the 2 multiplication tables. So if we divide by 2 and divide by 2, we get 5/6. Is that as far down as it can go? I believe so. Let's check the answer. Yep, 5/6. Number 9, 15 divided by 45. Those look like both in the 5 times tables. Somebody multiplied by 5 on those guys. So let's divide by 5, divide by 5, and we get 3/9. Oh, holy cow, that can go down even more. They're both on the 3 times table. So divide by 3, and we get 1/3. Let's double check our answer. Yes, indeed. There's our 1/3. Okay, number 10, 120 divided by 280. My goodness, that's quite a hefty problem there. Well, with zeros on the end here, they look like they both are in part of the 10 times tables because 10s just add zeros. So divide by 10 on the top and the bottom. And again, you're not changing the number. You're just dividing by the number 1, which doesn't change a thing. So if we divide by 10, we get 12/28. Let's do that again. Let me see. Those are both in the 4 times tables, so we can divide by 4 and divide by 4, and we get 3/7. Good. Let's double check our answer. 3/7 is correct. Number 11. On this one, it says to create each fraction with a denominator, that's the bottom number, and it's the one that names the fraction of 36. Okay, so what would we have to multiply this bottom by to get 36? Well, we'd have to do it by a 6. We got to do it on the top and the bottom, so we're really timesing by this big number 1. Well, let's see what we get. We get 6 on top and 36 on the bottom. And that's exactly right. 6/1/6 and 6/36 is exactly the same thing. All right, next one, number 12. We've got to create this with a denominator of 36. That means we have to times the 9 by something to get it to be a 36. Times by 4, times by 4. So that it becomes 20/36. Yeah, so this idea of getting new names, we can get a very specific name if somebody tells us to. All right, and the last one. We are multiplying to get 36. 12 times, I think that's 12 times 3. Times it by 3, 3/3. So 10 times 3 is 30, and 12 times 3 is 36. So yes, we've created them all with a denominator of 36.